All right, in this video, I want to go through another example. This will be a symbolic example. I know, Sam's favorite. Um, so this is a wheel that rolls without slipping, we assume. And we're going to assume that it has a radius r. And the task is to figure out an expression for the velocity of an arbitrary point on called B here on the edge of the wheel. We're going to assume that the center of the wheel moves with a velocity v. Okay, so we're assuming for whatever reason they usually put O for the center of the circle, and so VO is going to be just V, a symbolic expression. We're trying to find the expression for the vector VB. Our answer will be expressed in terms of R, theta, and the magnitude of V. Excuse me. All right. And we're going to use an instantaneous center of motion analysis. And from that, we're going to find omega. And then once we know omega, we're going to use that to find the velocity of point B. I have a picture, a photograph of what I have in mind here. So I'll switch over to that view and you can see what I'm thinking about. So here's a wheel. Its contact point is C. The point on the edge of the wheel is B. It's some arbitrary angle theta down from the y-axis. And we're going to assume that the velocity is in the x direction. Okay. So the first task is to figure out where could the instantaneous center of motion be. And remember, at the instantaneous center of motion, the velocity should be 0 and the motion of the object should look like a pure rotation. Well, clearly this is the point where the velocity is 0. So the IC equals the point labeled C in the diagram. Right? So that's the first thing to note. And then how can I find omega? To figure out omega, I need some point where I already know something. Well, the place that I actually know about already is that the center of the wheel travels with a velocity v. So I know that from that it tells me that the velocity at point O, which is just going to be v, the scalar analysis of this would look like this, times omega times r. Now we have to worry a little bit about minus signs here. This is rolling in the velocity, excuse me, the velocity would be positive, which means that omega will come out negative when we work it all out. So this is the formula for the magnitudes. And from the diagram, I see that omega should be negative. So I'm going to get that omega equals V over R with a minus sign, and it would always point in the z hat direction. So I'm going to rewrite everything with vector notation. That's what I find. All right. I'm after the velocity of point B, so I'm going to need to find R B from the instantaneous center. And that is simply going to be R. So I start at the center and I want to find the x and y position for point B. So it's going to be R plus R cosine theta in the y direction, and then R sine theta in the x direction. So it's going to be R times sine theta x hat plus 1 plus cosine theta y hat. Okay, so that's the position vector of B relative to the instantaneous center at C. And finally, to get my answer, I want that the velocity at B, well, it should be a pure rotation around the instantaneous center, so that should be omega vector cross R, B, C. And I'm just going to write all these things out here. So this is going to be omega times R times z hat cross sine theta x hat plus 1 plus cos theta y hat. This is going, and over here, this is what I have for omega, minus v over r. So that's going to give me minus v over r, the r's cancel. And then I have z hat cross x hat, that's y hat. So I get sine theta in the y direction. And then I have z hat cross y hat, that's going to be negative x hat. Or you can't leave all these extra minus signs. It's not quite like kissing your cousin, but it's close. So let's clean this up a little bit. Write this as v, the symbolic expression, that times 1 plus cos theta x hat minus sine theta y hat. And that is the formula for VB. Okay, so just to recap, we found the instantaneous center of motion. We used that to determine omega because we found a point where we already knew the velocity, so we could figure out what omega needed to be. And then once we had omega for one point, it's the same omega for all the points, and we could use that to find an expression for the velocity of some random point B. Okay, hopefully that was a helpful example.